Hello everyone, welcome back to the channel. So let's solve an interesting problem today, and I'm sure you will find it pretty engaging. So the problem is that there is a smooth circular table and that has a rim. So this, if you see, is a rim, and there is a vertical wall here, so that if you project a ball from here, point A, it will rebound at, let's say, point B and point C. And project the ball in such a manner that the angle that it makes with the, let's say, radius vector OA is theta. So the question is, what should be the value of theta so that the ball, after bouncing off twice, comes back to the point A? And given that the E is the coefficient of restitution here, so it's not a pure elastic impact, okay? And then we need to compute this value theta. If you want to pause the video, go ahead and do that and try it out, and then come back and check the solution. Okay, so let's start solving this problem. First thing is, there is some concept that I need to give you. Okay, you might already be knowing, but still. So when, let's say, there is a surface, I will take an arbitrary surface. Okay, here, let's say arbitrary surface. And if I have some object striking the surface and then bouncing off, okay, let's say with u is the initial velocity and v is the final velocity, and the given coefficient of restitution is E for the surface, okay, then how do we relate v and u using E? So this is something that we do using Newton's experimental law. And what you need to remember here is you have to take the normal at that point. So first of all, take the tangent, okay, and let's say at this point P. Then take the normal, okay, normal to the tangent. And there are two things. So the first equation that you should remember is E equal to V2n prime minus V1n prime divided by V1n minus V2n. Okay, I will explain what this is. And the second one is that along the tangent, so this was about normal, along normal, and then along tangent, the velocity is constant. It doesn't change. Okay, so let's see what we mean here by this. Okay, this is important. Right now we have only one object which is bouncing, but there could be a case where, let's say, this surface is also moving because of impact. So we need to pick two objects. Okay, during any impact, there are going to be two objects. And the second one becomes important if the second one is also moving. So in this case, let's say this is object number 1. So this is also 1. And this one is, let's say this surface is object 2. Okay. So it says that E is equal to the velocity of the second object, this object, along the normal. Okay, this is vector. Remember, all of these are vector. So we need to take along the normal. Okay, that's why this subscript n is coming. So velocity of second object along the normal minus velocity of one object after the collision. This is after the dash is after the collision. So here v1 is initial velocity of 1, v2 is initial velocity of 2, v1 prime is final velocity of 1, and v2 prime is final velocity of 2. Okay, that's the description. So let's say in this case, if this is the angle alpha and this is angle beta, and let's say 2 is not moving, then we will write E equal to, so what is the speed of second object after the impact? 0, because 2 is not moving, so 0 minus velocity of first object along normal, so this is given V, and along normal it is V cos beta. V cos beta divided by velocity of one along normal. So this is the velocity of one here, and if along normal will be u cos alpha, but it is going to be in the negative direction. So negative u cos alpha, and initial velocity of 2 is also 0. And therefore you get E equal to V cos beta by u cos alpha. And then hence therefore we also write it V cos beta equal to EU cos alpha. Typically we always deal with something like this, and this is true only when the second object is not moving, the object with which the object 1 is impacting or hitting. Okay, but so this is the formula, this you should remember, always use this. This will come very handy, and this will also work when object 1 and object 2 both are moving. You just need to treat them as vectors, okay, so that you take the direction and the component along the normal. You need to pick the normal, and normal is going to be perpendicular to the tangent. And the second one is simply that along the tangent the velocity is constant, so which means that initially it is u sine alpha, and then finally it is v sine beta. Okay, so this will be also constant. Okay, you get this? Okay, so if you get this, then more or less the problem is already solved. Okay, so let's see. At point B, if we consider, and if we draw this radius vector here, so this is theta, then this is also theta because OA and OB both are R. Let's say R is the radius, and let's say this is alpha. Okay, and then if you connect, this is going to be alpha, and let's say this is beta. Okay, so this is going to be also beta. Okay, so what do we see here? We see that alpha plus theta plus alpha plus beta plus beta plus theta, this is equal to pi, this sum of all the angles, that means 2 alpha plus 2 beta plus 2 theta equal to pi, and therefore alpha plus beta plus theta equal to pi by 2. Okay, so let's say this is our equation A. Okay, this is all theory. Okay, but you should definitely remember this properly. Okay, now let's consider at point B. So at point B, let's say if this is u and this is v, the final velocity, then using this equation, okay, so we can write E as the two, let's say the table is second object and the ball is first object. So the second object velocity is always 0, so 0 minus the velocity of first one after the impact along normal. So normal is always going to be towards center, right? So this one is normal, right? Okay, so what is that? That is v cos alpha divided by initially the velocity of object 1 in the direction of normal is minus u cos theta. Therefore we can write v cos alpha is eu cos theta. Okay, and then we also know that along the tangent the velocity is not going to change. Okay, so which means that v sine alpha is equal to u sine theta. Okay, now let's eliminate v, okay, from these two equations. So that would mean u sine theta by sine alpha into cos alpha. I am just taking v from here and putting it here, is equal to eu cos theta. Okay, therefore we get cot alpha is equal to E cot theta. Okay, okay, and then you can again do the same thing for point C. or we can just use the symmetry and write the second equation as well. So we can write the second one as cot beta equal to E cot alpha, and therefore this could also be E into E cot theta, which is cot beta we can write as E square cot theta. Okay. Now note that I have seen many will try to write the same equation here, but that's not going to be true because it is just reaching here. It's not saying that after hitting here also it will follow the same path. Okay. That would be a different question. Okay. Now if this is true, then we can just use this equation A, and try to plug in alpha and beta in terms of theta. So which will be, let's say, we can write alpha plus beta equal to pi by 2 minus theta. So take cot both the side. Okay. And then this is tan theta. Okay. And this is cot alpha, cot beta minus 1, cot alpha plus cot beta equal to tan theta. And cot alpha is nothing but E cot theta, right? And cot beta is E square cot theta minus 1. And this is E cot theta plus E square cot theta. And this is nothing but 1 by cot theta. So this can cancel out. So this eventually it becomes EQ cot theta minus 1 into E plus E square, and therefore cot theta is 1 plus E square by EQ. This is, by the way, cot square theta root under this. Okay. Or you can write tan theta as EQ by 1 plus E square. So that's the expression for theta. Okay. So for E, if we throw at this angle, then it will eventually come back to the same point. Okay. So I hope this was clear. Now let me ask you another question. Okay. Let's think about this question now. Okay. Now similar question, but little bit of twist here. Okay. So now there is a pool table. Let's say it's a pool table. Okay. And the side is, let's say, A and the other side is B. Let's say this is A and this side is B. And again, we throw a ball here. It's a pool ball. We hit it so that it is making angle theta like this. And then after 3 bounces, it comes back. And the question is that what should be this value X, let's say. Okay. Let's say this point is P. So X as AP should be what? So at what point should I launch this ball with angle theta so that it comes back? And also find theta in terms of E. And again here also coefficient of restitution is E. This is given. Can you try this out and see if you can solve this? Okay, let me start solving it now. So let's say this angle is theta and this is the first hit is happening at Q. Okay. So let's take a normal here. Okay. Same way, normal. And if this is theta, this is 90 minus theta. So this one is theta. Okay. And let's assume that this angle is alpha. Okay. So at this point, if I write E, it should be again, I'll take ball as the object 1 and the table as object 2. Table doesn't move. So 0 minus. Now here, if you see, this one is going in this direction, right? Like this. Okay. And it rebounds here with velocity V. Comes with U, goes with V. So V sine alpha. Okay. minus u cos theta. Okay, I hope you see this. So v sine alpha is eu cos theta, and then tangent is just this line. Okay, so along tangent the velocity doesn't change, so u sine theta is equal to v cos alpha. Therefore v is u sine theta by cos alpha. So we'll put v here and it will become u sine theta by cos alpha sine alpha eu cos theta, and therefore this becomes tan alpha as e cot theta, right? Okay, you see this? Okay, so far so good. Now we can again take this point as r, and let's say this angle is beta, right? Okay, and if we write the same equation with this normal, this time this is the normal. Okay, then what do we get? We will get tan beta as e cot alpha. Okay, so from here, which means tan alpha is e cot beta, and if we replace tan alpha here with this, then we get cot beta is cot theta. That means beta is theta, and which is very commonsensical, because if the ball has to come back, then this angle has to be theta as well, and that's what we are getting. If beta is theta, and if you assume this one is gamma, then gamma should also be theta. Okay, so what we get here is that the alpha is equal to beta equal to gamma, and that should be equal to theta. Okay, so we can write tan alpha as tan theta equal to e cot theta, which means tan square theta is e, and therefore tan theta should be root e. Okay, now if we know this, then all we need to do is calculate x. So how do we calculate x? So we can take, let's say this is r, this is s. We can take this triangle and this triangle, and we can say that they are equal triangles, congruent, and then we can equate RC with x. Okay, so to compute RC, we need to compute BR, and therefore we need to compute AQ. Okay, so from triangle APPQ, theta is AQ divided by x. So that means AQ is x tan theta. Okay, and again from triangle BRQ, tan alpha, which is again tan theta, is equal to BR by BQ. BR is BQ tan theta, and BQ is nothing but A minus AQ, which is x tan theta. Therefore RC will be B minus BR, which is B minus A minus x tan theta, and that should be equal to x also, because this is also x by symmetry, and therefore we get B minus A tan theta equal to x1 minus tan square theta, and therefore x equal to B minus A tan theta is root E 1 minus E. Okay, so this is the expression for x. So if we throw a ball at distance x with angle theta, and theta is not given, theta you can compute using E, and that is root under E, tan theta is root E. So I hope you like this video. Please do subscribe the channel and also share this with your friend. Thank you for watching. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.